Hello everyone. Today I'm gonna give you a demo on BRI application, Bluing Reflectivity Integration, a method for seismic spectral enhancement. So after downloading all the materials from GitHub, you'll see all the Python script and this information in this folder. So you can put your seismic data next to the Python script. In this example, I've selected the actually open data website and just download it. The information for downloading this data already provided in the description. So all you need to do is just go to the directory bar and use a command prompt or CMD, and then just type Python name of BRI script, the GUI one, the graphical user interface one, and then just press enter. So you'll see the main actually interface of the BRI application. The name is displayed at the top left hand side. So if you go to the menu bar at the beginning, you will see the load original seismic data. By clicking on this, you can select your seismic data in segway format. In this example is a 3D volume, and when you click on open, then actually it depends on the size of data. It takes a bit of time to load and read all the information, including the geometry related byte location. So, and it is how the main interface of BRI application looks like. So once the data is actually loaded and read, the data is displayed. So the message that you receive said that okay, seismic data was loaded successfully. You can close it, and at the top of the plot you will see the information of the data, including seismic file name as a post stack, this example 3D, number of trace, number of samples, sample rate, start time, trace length, and so on and so forth. And for 2D, it said that all the traces are displayed, but for 3D, the traces are middle in line or only are displayed. However, the BRI will be applied to the entire traces. So what we see here is actually the middle in line of the data. So at the top left hand side there is a button set location map. If I click on that, then I'll see the XY coordinate map, and by zoom into this part I can see the bin center of all the traces. At the middle top you'll see the BRI spectral enhancement. So before clicking on that, all the other bottom are gray out. So once I click on that, the BRI or Bluing Reflectivity Integration is implemented. For technical information and details, you can refer to the provided PDF file. So to shorten the recorded video, I skipped this part. So I try to explain everything in the PDF and about the Bluing Reflectivity Integration and its differences with seismic spectral bluing. Once the BRI is run, then all the bottom will be activated. So you can toggle between original seismic display and BRI seismic display to compare the results. In order to have a better comparison between the results, let me just limit the X and Y scale. So here in the navigation toolbar provided in the matplotlib, I can just limit it easily. So for the y-axis I select 1000 at top, and for bottom is 1500. For X I select 50 to 150 and just click OK. So here is the original seismic display, and if I toggle on BRI seismic display, you will see that the seismic vertical resolution already enhanced, and the sub seismic features and thin layers are disclosed using the BRI application. So there are some other quality control tools. One of them is overlay comparison. If I click on that, I get this plot. So I can again zoom around the some actually desired location and see that what is the difference between the blue curve and the orange color curve, that is BRI original. So as you see here, it shows that the thin layer beyond the tuning thickness are revealed better in the BRI results compared to the original one. And for your kind information, the overlay comparison is done and for the trace in the middle of 2D line or center of 3D survey. The other quality control tool is also available, that is amplitude spectrum. If I click on that, then I get the amplitude spectrum, and I can compare up to Nyquist frequency. So as you see, for the lower frequency, the amplitude more or less is the same, but for higher frequency, more than 40 Hz, that is dominant frequency in this case, you'll see that the BRI shows the higher frequency actually has higher amplitude. It means that the higher amplitude for higher frequency are boosted in BRI, and then that's why the seismic vertical resolution are improved. So at the end, if you want to save the output, you can just go to the menu bar and then select the Save BRI Seismic Data, and the data is saved with the same geometry in the same folder with the extension of underline BRI next to your original input. So again, you will receive another message that said, okay, the data already saved successfully, and you can close it. In case you load pre-stack data, since it's not supported, or angle gather or pre-stack, then you come across with this message that the pre-stack is not supported. Please make sure that the inline and crossline byte location also are consistent with your data. So I hope that you can run it on your own data set and get your desired results. Thank you so much for your kind attention.